Okay, so let us continue. So we have done the structure wall design using ETABS and manual calculation with the ACI limitations. So there is a limitation on the maximum spacing of the wall. The ACI 318.14 limits for the maximum spacing reinforcement for the wall, and it is defined in section 11.72 and in section 11.7.3. That for the spacing of the longitudinal reinforcement, the spacing S of the longitudinal bars in cast in place wall should not exceed lesser of 3H and 18 inches, right? And the other condition that is not for us, right? So the spacing limit is 3H in 18 inches. So in our case, we have the thickness of the wall is 12 inches. It comes out to be 36 inches center to center. And the second one is the 18 inches. If you want to see if the reinforcement is required for the in-plane self-strain spacing of the field should not exceed L by 3. You can also check it, but we are on the safe side if you check it, right? So the limit for the maximum is 36 inches for the flexure and 18 inches. So this is what we governing, that is the value for, in our case, for a thickness of 12 inches, it should not be greater than 18 inches. In our case, the left wall is 15 inches. So if you multiply with 15, it will be 45 inches or 18 inches. So again, 18 inches is governing, and we have provided 12 inches and 12 inches, which is not greater than 18 inches. So we are on the safe side. Another check is on the transverse reinforcement, that the transverse reinforcement in cast in place wall should not exceed lesser of 3H and 18 inches, same. And there is another limit on the L by 5, which is also comes out to be lesser, which we have provided. You can also verify it. But in our case, the governing is 18 inches, and in share we have provided 10 inches, 12 inches, and 12 inches. So in our case, the value is not greater than 18 inches in either case, in share and in this flexure. So this limit for the maximum reinforcement has been satisfied, right? So this is how you check with the code and do manual calculation with the codes and take value from the ETABS. So this was the whole story about the design of the structure walls. The next is the design of the ramp and two-way slabs according to ACI 318.14. ACI 318.14 limits for the minimum reinforcement for two-way slabs on ramps, because ramps may be designed as a two-way slab or one-way slab depending upon the pattern which you are using. And it is defined in table 8.6.1 is minimum for the non-prestressed two-way slabs is that if you are using FY less than 60, if you are using 40 PSI, 40,000 PSI, this limit is for you. And if you are using 60,000 PSI FY value or greater than 60, these two limits must be satisfied for the minimum reinforcement. So in our case, we have FY 60 and our H is 6 inches. So second case is applicable in our case. So if you do this calculation, the first one is 0.0018 into 60,000 divided FY. So if you are using FY 60, so these two will be cancelled, and you are left only with 0.0018 into AG. AG means the area of the gross area of the slab, which is the thickness and length. So if you are calculating per unit length, we have to multiply with one strip, which is 12 inches. We have multiplied this 12 feet because we are using a strip. So it is 0.0018 into this is thickness into one strip 12 inches divided by this, which is come out to be 0.13 inch square per foot. This is for the first, and for the second it is comes out to be 0.0014 AG, and our in AG consists of H, which is 6, and this is 12, which is in 1 feet in inches. So we are getting 0.1 inch square per foot, and you have to select the greater of this. So this is the governing. So if there is a manual calculation or ETAB is not giving you a value greater than this, so you have to provide this much minimum reinforcement in your slab. So let us go to the ETAB. And let us so for the design of the slab, you have to go to the design, concrete slab design, and click on the revise preferences, from where you can select your design parameters. You can select your minimum cover for the slab, and this is for the post tensioning, and you can insert this top and bottom clear cover, which is normally is 0.37 for the slab, right? Again, you have to go for the slab, and you can check on this revise flexure design overrides. So it is not clickable because we haven't selected any slab. So let us show the slab. So let us go to the select object type and select floors. And now that option will be clickable. And go to the concrete slab design, revise flexure design overrides, and click on this finite element method based. So from where you can select this grade of the steel in which you want to use in your slab. So in slab, we will be using grade 60 steel. So you will select grade 60 and you will click on OK. So now the ETAB will design your slab accordingly for the grade 60 steel. The next is the design combos. You can select the concrete slab design, and then you can select the desired combination as we have done in for the columns, for the beams, for the shear wall. All of these are the same procedures, right? And then you can select a specific story if you want to design, because you do not want to your the system to be very heavy, because it will be designing the slab for all of the stories. If your slab is same for from the basement to the top, or in some story, you can select either. But we will, for our simplicity, we will design only 2 floors, because ground floor is different. It consists of the ramp, and from the first floor top we have the same stories. We will select only these 2 and click on OK, and we will start the designing of the concrete slab. The option is uneven. Because you have to run the analysis again, because we have changed some.
درس سلاب سريع كانوا بيابا ده غشي.
No, Shuman. So we have to run the analysis again. Let us see if this is applicable or not. So during this, if you have any questions, you can ask. There might be some issue, because in here it is showing combinations are the same. Because I have run it in here. Let us go.
So that's shear واسع كده بس بدي كتير. ديك ران شبابي. جاكم كده نشوف تاكتيك كسر وسيف.
So ديك بالديزاين زما كنت ساقي تاست بروسيجر خو لاغي سيدا تاوسين ديزاين كوي. Grade basing select كوي. Load combination basing كوي. Storage basing select. This was the overall discussion on how you select the different stories if you do not want your system to be heavy to design all of the stories, and how you select the story types and the load combinations and the desired code you have already selected for the concrete. So this is now the ETABs are doing the design of the slab. You can see on the left hand corner, they're designing slab elements. So it is designing your slab on the basis of finite element method, right? You can also design your slab using strip design method, but you have to insert design strips in your slab, column strips and mid strips. That is the DDM method. So while it's doing the analysis, so if you have any questions in previous sessions or in today's sessions, you can ask. अच्छा क्वेश्चन नहीं
अच्छा सर जो पिछले पैनल्स पे जो हमने वो वॉशरूम के पैनल्स पे जो हमने लोड डाला था 190 पीएसएफ जो आया था
जी जी
तो वो सर 50 प्लस 190 240 पीएसआई हो जाएगा टोटल।
नहीं फिर आपके पास वो बहुत ज्यादा लोड आएगा है तो उसकी फिर आपकी 50 की जरूरत नहीं अगर आप 59 भी लगाए क्योंकि 190 पीएसएफ इज अ ह्यूज लोड।
तो सर स्लैब का भी तो है
अगर आप लगा भी ले तो इतना फर्क नहीं पड़ेगा, लेकिन नॉर्मली इसको नहीं लगा, अगर आपके पास लोड 100 से ज्यादा आ जाए तो फिर उसको 50 को फिर नहीं लगाया जाता। फिर आपके पास जो स्ट्रक्चर है वो आने के लिए, क्योंकि आप देख सकते हैं कि आपके पास ये 1.2 टाइम्स इंक्रीज हुआ है, फिर आपके पास 10% और इंक्रीज हुआ अगर आपके पास अर्थक्वेक आ जाए 1.32 तक गया है। सो द स्ट्रक्चर इज ऑन द वेरी वेरी सेफ साइड। तो नॉर्मली जब आप डिजाइन पे आएंगे तो आप प्रैक्टिकली बहुत सी चीजों को इग्नोर करेंगे। ये तो बहुत चीजें आपके पास किताबी चीजें है, लेकिन आप प्रैक्टिकली इसको करेंगे तो क्लाइंट आपको कहेगा कि यार ये तो बहुत ज्यादा अनइकोनॉमिकल है, ये चीज है वो चीज है, लेकिन आप कोड को वायलेट नहीं करेंगे, लेकिन बहुत सी चीजें आप फिर इग्नोर करेंगे। तो आप जब जाएंगे आपकी प्रैक्टिस होगी तो फिर आप देखेंगे।
ठीक है सर, मैं स्ट्रक्चर इंजीनियर तो नहीं हूँ, मैंने बनना तो नहीं है, लेकिन मैं वैसे एक मैकेनिज्म समझने की कोशिश कर रहा हूँ।
अच्छा तो आप
और
क्या
सर
कर
एक
रहे हैं?
सवाल, मैं सर 15-16 साल से साइट इंजीनियर के तौर पे काम कर रहा हूँ, मतलब कि अभी तो मैं असिस्टेंट रेजिडेंट इंजीनियर हूँ एक
अच्छा
हाईवे
जी, तो
प्रोजेक्ट पे
ये
हूँ।
ये कोर्स डिजाइनिंग कोर्स, ये डिजाइन को समझना, ये कहाँ पे रेनफोर्समेंट प्रोवाइड करनी चाहिए, कहाँ पे डिफ्लेक्शन ज्यादा होगी, ये चीजें साइट इंजीनियर के लिए बहुत जरूरी है। क्योंकि अगर आप साइट पे काम कर रहे हो और आपके पास ये ड्राइंग्स इस तरह आई है कि वहाँ पे रेनफोर्समेंट की जरूरत ही नहीं, या कि किसी जगह पे जरूरत है उसने प्रोवाइड नहीं की, तो आपके पास इनफ नॉलेज होना चाहिए कि यहाँ पे बेंडिंग मोमेंट्स आएगी, यहाँ पे शेयर आएगा, तो यहाँ पे रेनफोर्समेंट होनी चाहिए, तो आप ऑब्जेक्ट कर सकते हैं उस कंसल्टेंसी पे या ड्राइंग्स पे कि ये ड्राइंग्स ठीक नहीं, आप काइंड इसको रिवाइज कर दें। ठीक है
बिल्कुल सर।
ठीक। तो ये
सर
आपके
जब आप
पास जी
जब आप प्लेन व्यू में जाते हैं और फिर नीचे विंडो में वो कमांड स्टेटस में आप ऑल स्टोरी लगाते हैं, फर्ज करें आप प्लेन व्यू में सेकंड फ्लोर पे खड़े हैं और ऑल स्टोरी क्लिक करते हैं, तो सेकंड स्टोरी से अबाव पे जाएगा या बेसमेंट से लेकर टॉप तक ये सारा अप्लाई होगा?
अगर आप सारे स्टोरीज को सेलेक्ट करें, अगर आप टॉप पे होंगे या मिड पे होंगे या आपके पास जो नीचे होंगे, तो सारे स्टोरीज में आपके पास सेलेक्ट होंगे, ये रेस्पेक्टिव कि आप किस प्लेन में काम कर रहे हैं।
ठीक है सर।
ठीक है
सर एक और, ये सेप जो इंस्टॉलेशन है वो मैं कर रहा हूँ, लेकिन मुझे वो क्रैक जो है सही तरह उसका नहीं इंस्टॉल हो रहा। एक का तो मैंने फायरवॉल ऑफ कर दी है, लेकिन फिर उसका क्रैक उड़ जाता है। दूसरे सिविल एफडीसी से मैंने किया हुआ है तो उसका क्रैक सही नहीं इंस्टॉल होता।
तो आप रन एज डेट से चलाए ना, रन एज डेट से करिए। ये जो मैं जितनी भी सॉफ्टवेयर चलाऊँ ये रन एज डेट पे चल रहा है।
मेरे साथ तो वो फाइल नहीं आता रन एज डेट।
चलिए एट द एंड ऑफ दिस सेशन मैं आपको बता दूंगा कि रन एज डेट क्या चीज, इसको आपको ये आपके यूट्यूब में बहुत सी वीडियोस मौजूद है, आप देख सकते हैं।
Excuse me, sir.
जी जी
सर लिंक लिंक में किए सर,
जी
हमारे साथ इंस्टॉल हुआ है, लिंक मैंने शेयर किया ग्रुप में सर, इंस्टॉलेशन लिंक
काइंडली
वीडियो भी
आप
है सर।
ये आपके पास जो ये
वो
आपके जो सीनियर है आपके भाई है, इनकी काइंडली आप हेल्प कर दे। मैं भी आपके पास कुछ यूट्यूब की लिंक्स वगैरह शेयर कर दूंगा, तो आप
मैंने
उसको
शेयर
वीडियो
किए सर,
वो
शेयर
आप
किए
देख ले
सर,
कि
ये
रन एज
लिंक
डेट पे आप किस तरह इसको क्रैक कर सकते हैं। अगर फिर भी ना
जी
हुआ
जी
तो
वो
फिर भी मैं आपको लाइव यहाँ पे दिखा दूंगा किस तरह होगा, ठीक है जी।
सर,
सो लेट अस
जो वीडियो
फिनिश
मैंने
दिस
शेयर
वर्क।
किया, जी सर जो वीडियो मैंने शेयर किया वहाँ पे रन एज डेट की जरूरत भी नहीं है सर।
चलिए जी ठीक है, जो मैंने ये
ठीक
शेयर की आप ट्राई कर ले, कहीं पे रन एज डेट पे इंशाल्लाह कल कर देंगे,
ओके सर, ओके
ठीक है।
सर।
So the analysis has been done. So now you can see the reinforcement in the slab. So how do you verify that it is the reinforcement? You can see that on the top it is plain view 7Z and all of these, and it is saying the slab finite element design, and it is showing you top rebar intensity inch square per foot. So you are seeing the reinforcement in inch square per foot. So now you can see that at the mid span there is no demand for the top reinforcement slab, but at the supports there is a demand for the shear reinforcement, the negative reinforcement. Now, because we all knew that there is no negative moments at the mid span, because we have the positive moments at the mid and the negative moments at the support. So now let us go to the design. You have to go to design and go to the slab design and click on this display flexure design. So now you can see there are different options. The first one is that you have to select whether it is the finite element based or strip based. So we have finite elements, and this is enveloping, this is, and on the right side there's reinforcement direction and location. And if you select direction 1 bottom and click on apply, it will show you the reinforcements at the midspan, right? So this is the direction 2, but first you have to confirm the direction for the slabs. You have to go to the shell local axis, because the ETAB is showing this reinforcement on the basis of the local axis. So now you can see the slab direction. This is the X direction and this is the Y direction, and it is coinciding with the global direction of our system. So right, so the global direction is the X is same for as the our slab direction. Now you go to display, design, concrete slab, and flexure design, and check for the reinforcement in the X direction. So this is the reinforcement ratio. It is giving you, it is in inch square per inch. I think, let us make it use default. So now it is in inch square. So now we have applied the SDL value maximum for the this panel. You can see this contours is greater in this region, and it's giving a value of 0.17 inch square per foot. And I haven't applied this imposed minimum reinforcement because there is too much less reinforcement required for the applied loads. But if I click on the impose minimum reinforcement, you can see that the ETAB have applied the minimum imposed reinforcement ratio on your slab, and now you can see that the minimum reinforcement is 0.1296 all over, and at the support it is showing you 0, because there is no need of the positive reinforcement at the support, and the minimum reinforcement for the slab is 0.1296 inch square per foot. Same for the direction 2 bottom. So these are the contours. in the two direction. This is the y direction. Direction 2 is the y direction and direction 1 is the x direction. And it is showing you the minimum reinforcement of 1.296, and in some places it is 0.13, right? So this is how you check the reinforcement. It is 0.196 inch square. So let us do check with the required. So in our case, the minimum reinforcement for using the manual calculation, it is 0.13 inch square per foot, and ETAB is giving us again 0.13 inch square per foot, as you have seen, and 0.1296 inch square per foot. So you will go for the higher value in both the direction because it is two-way slab. So we are getting 0.1296 inch square, and in here it is 0.13, and we have confirmed it using the manual calculation that is 0.13 inch square per foot. So from ETAB we will select 0.13 inch square per foot to be on the safe side. This is for the bottom. And for the top, we'll go in direction 1 top. And you can see it is giving me the value of, you have to check at the face of the support of the column. It is 0.16. It is 0.18. So these are the major columns in which the load is maximum from all of the span. So it is 0.18. It is 0.18. It is less than this. It is 0.16. This is 0.16. So here it will show you maximum value, but we have to select at the face of the column. It is 0.22, and here it is 0.21, right? So 0.22, this is 0.14. So in some cases you can ignore these, because if you apply 0.22 to all of the span, it will become very uneconomical. So we will select this 0.18 for all of the negative. And in the direction 2, we are getting more reinforcement in direction 2 because it is the shorter direction, and in short direction we have maximum negative moments. So we will select at the face of this column. It is 0.28, 0.28. This is 0.3. This is 0.3, 0.26. So we will select 0.3 for the top, because you can see in many places it is giving me greater than 0.26 or equal to 0.26. So we'll go for the top as 0.3 inch square per foot. Right, so let us find the spacing from it. If we use number 4 bar for the bottom, so it will be 0.2 divided by 0.13 into 12. It will give us the value in inches, which is 0.2 divided by 0.13 into 12. So it is 18 inches, right? So it is way high than the limit. And how did I know that? We will see in a while. So we will reduce the spacing. Let us say it is giving me this value, 18 inches center to center. Right, for the top it is 0.2 divided by 0.3 into 12. It will give you value in inches, 0.2 divided by 0.3 into 12. It is 8 inches. It is quite reasonable. So it is 8 inches center to center. And it is number 4 at the rate 8 inch center to center. And it is number 4 at the rate 18 inch center to center. Right. So this is how you calculate the values. And let us go to the, there is another method. If you are not doing this, there is another method in ETAB. Inside the ETAB, we will do that. So let us check the maximum spacing. So the ACI 318.14 limits for the maximum spacing of reinforcement for two-way slabs and ramp is defined in section 8.7.22. And for the non-prestressed slab, the maximum spacing defined of tunnel bar shall not be lesser of 2H or 18 inches. In our case, the slab thickness is 6 inches. So if you multiply 2 into 6, you are getting 12 inches center to center, and the next limit is 18 inch center to center. So you cannot provide spacing greater than 12 inch center to center. What we are getting is 18 inch center to center. So in order to fulfill this maximum criteria, maximum spacing criteria, you have to reduce this spacing into 12 inches. So finally, you have to provide number 4 at the rate 12 inches center to center. This is the final result for the bottom. And this is for the top. Right. So now let us go to the ramp. And we have to select properties, slab, and select that ramp you have defined, and view show selected object only. Have to go for the 3D. So now you can see this is the ramp which has been designed, which we will be designing is a two-way. You cannot see that in plane because it is an incline. So now you can see the reinforcement required for the ramp. You go to design, concrete, slab flexure design. And you have to go for the bottom. So this is the bottom reinforcement required. And it is 0.1944 inch square per foot in direction 2. And in direction 1, it is 0.1944, right? So this is for the slab. For the ramp, bottom is 0.19 inch square per foot. And the top is top is 0.22 inch square per foot in direction 1, and in direction 2 it will be more. It is less in this direction, so we will be using 0.22 for both direction for the simplicity of the drawings, because there will be significant difference in these two, right? So we will take 0.22. So the top is equal to 0.22 inch square, right? So the bottom is, if we use number 4 bar 0.9 into 12, it is 12 inches, right? And for the top, 0.2 divided by 0.22 into 12, it is 10 inches, right? So we will be using number 4 at the rate 12 inches center to center bottom, and for top we will be using number 4 at the rate 10 inches center to center. So these are the practical values which normally use in our design. You can also use if you are designing a high-rise building. So this is designed for the ramp, and it is again inside the permissible and allowable maximum spacing of the bars in both the directions, right? So this is how you do the design for the slab and ramps. Another interesting option is in ETAB is to use the available spacing and bars you have to select. So let me click on this typical uniform reinforcement specified below and select, let me show all. And click on the plan view. Now I want to verify, or if you do not want to do this calculation, you can directly check the spacing by selecting bar size and spacing. You have to click on this typical uniform reinforcement and you have to select the bar size. Let's suppose select the bar size number 2 and give it in 12 inches and click on apply. It is giving you 0 reinforcements, but in some cases it will give you reinforcement that this much reinforcement is required, because if you give number 2 bar at the rate 12, it will work for you. But in order to satisfy the minimum reinforcement criteria of ECI, you have to go for the number 4, right? So let us go to the number 4, which we have given the value for the slab, that is number 4 at the rate 12 in center to center. So you have to select number 4 and give 12 center to center and click on apply. So you can see that it becomes 0 because we have selected the top bars. We are going to see the bottom. So bottom direction 1 you have to select, and then select bottom bars size and space and click on apply. So now you can see there is no reinforcement required if you provide at number 4 at the 12 inch center, right? So let us change it to, let us suppose I provide it at number 4 feet center to center. So it will tell you that if you provide number 4 at the rate 48 centimeters, this much reinforcement is still required, right? So if you keep on decreasing these values, spacing, so the reinforcement will decrease accordingly, right? So it will work in 24 inches as well, but in order to fulfill the maximum spacing of the ACI, you have to go for the 12 inch center. In this way, you can verify your provided spacing in your slab using this command, right? In the other direction, it is showing you the extra reinforcement, but these are the opening reinforcements. Because we have opening in here, it is not showing because the openings are off and due to the demand of this lift. So normally diagonal bars are provided in this region of the opening, right? So that's why it's not fulfilling this criteria. For the top, you have to select that bar. You have to give the spacing and click on apply. And so 0 bars are showing because you have calculated this top at the rate 8 inches. But if you provide at 10 inches, it would also work, right? And the other direction, click on apply, right? But in other direction 2, it is not fulfilling the criteria because some of the reinforcement has been shown in addition to number 4 at the rate 10 inches. If you make it 8, it will reduce, right? But still it's giving you reinforcement under the column because you do not have interested under the column, you are interested in at the face of the column, right? Because under the column there will be beam reinforcement, there will be slab reinforcement. So you do not have to take the maximum value under the column, because if you take that, it will become very uneconomical structure for you, right? So this is how you do the slab design using manual calculation, taking the value from the ETAB, or you can verify it by using this method, right? So we will be using this method and taking value from the ETABs in our rough design as well, right? So this was the whole story about the design of the structure walls, beams, left walls, shear walls, retaining walls, and then slabs and ramps. And we will meet each other after 10 minutes, because let us perform the prayers. Or if you want me to continue, because we will perform the prayer after that. And we will start the session 9, which is the serviceability requirement. And it is very short. We will end up this in 20 or 30 minutes, right? So this time is over. It is 2 minutes. So let me stop this, and I will share another link so we can start our serviceability requirements, right?